Okay, today we have fantastic topic about orifice. What's orifice? Let's me definition of the orifice. Orifice, an opening in a tongue through which the liquid flows out. Orifice, an opening in a tongue or vessel through which the liquid flow out, is known as the orifice. This hole or opening is called an orifice. So as long the level of the liquid on the upstream side is above the top of the orifice. Orifice is used to measure discharge. An orifice may be provided in the vertical side of tongue or in the base of the tongue. This is the cross section of the tongue. This opening or hole is called orifice. The above portion is water-free surface, and the bottom side and this portion left and right side is the wall thickness of pot or wall. And classification of the orifice. We have different types of orifice. It depends upon which part, shape, size, different types of orifice. Classification of orifice according to shape of orifice. According to shape of orifice, we have circular orifice, we have rectangular orifice, we have square orifice, we have triangular orifice. We have 4 types of orifice according to shape of orifice: circular, square, rectangle, triangular, triangle. Number 2, according to size of orifice. According to size of orifice, we have 2 types of orifice. One is a small orifice, another is large orifice. What's a small orifice? A small orifice, D is the diameter of the orifice, and H height of it above the center of orifice up to water surface, free water surface. From free water surface up to center of the orifice is called, this height is called H, and diameter of orifice is D. If it of orifice it's greater than 5 times diameter of orifice, it's called a small orifice. And if it of orifice is less than 5 times of orifice, diameter of orifice, is called large orifice. And number 3, according to shape of each. According to shape of each, maybe we have 3 types. We have 3 types of orifice. The first one is sharp edge orifice. The second one, bell mouth orifice, and the third one is square orifice. These are the figure across cross section of the orifice. These 3 types of orifice: sharp, bell mouths, and square orifice. Number 4, according to nature of discharge: free discharge orifice, fully submerged orifice, and partially submerged orifice. We have, according to nature of discharge, we have 3 types of orifice: free discharge orifice, fully submerged orifice, partially submerged orifice. And what is free discharge orifice, fully submerged orifice, and partially submerged orifice? These are the figure: fully submerged orifice, partially submerged orifice, and free surface, free discharge orifice. The first one, free discharge orifice. When discharge of orifice is free in the air, it's called free discharge orifice. When orifice discharge the liquid into some other vessel containing the liquid and the outlet is completely submerged, the orifice is called submerged orifice. When the orifice discharges the liquid into some other vessel containing the liquid and the outlet is partial under liquid, the orifice is called partially submerged orifice. These are the classification of orifice according to different types. And we have one more topic, vena contracta. Vena contracta. Vena contracta. This is the figure of the vena contracta. Consider a tongue fitted with an orifice as shown in this figure. The liquid particle, in order to flow out through orifice, move toward the orifice from all direction. A few of the particles first move downward, then take a turn to enter into the orifice, and then finally flow through it. It may be noted that the liquid particle lose some energy. While taking turn to enter into the orifice. It has been thus observed that the jet, after leaving the orifice from the wall of the tank, where jet is more or less horizontal, the section CC at the distance d by 2 from the face of the wall of the tank, at which contraction of jet is maximum, is known as vena contracta. This is the vena contracta, and we have shown in this is the cross section of the vena contracta. We have some more topic about coefficient, hydraulic coefficient. We have three types of hydraulic coefficient: coefficient of contraction, coefficient of velocity, coefficient of discharge. Coefficient of contraction CC, coefficient of velocity CV, coefficient of discharge CD. First one, coefficient of contraction. Coefficient of contraction is area of jet at vena contracta by area of orifice, or actual area by theoretical area. Its CC is equal to A actual area by theoretical area. The average value of CC, coefficient of contraction, is about 0.64. And number 2, coefficient of velocity. Coefficient of velocity, actual velocity of jet at vena contracta by theoretical velocity. CV is equal to actual velocity by theoretical velocity. Theoretical velocity is equal to root 2gh. Value of CV varies from 0.95 to 0.99. Number 3, coefficient of discharge CD. Coefficient of discharge, actual discharge by theoretical discharge. Its CD is equal to actual discharge by theoretical discharge. The value of coefficient of discharge is about 0.62. Relation between CC, CV and CD. Coefficient of contraction, coefficient of velocity and coefficient of discharge. We have coefficient of discharge, actual discharge by theoretical discharge. We have one equation, discharge equation of discharge is equal to A into V. We can substitute from upper side and lower side. Actual area into actual velocity by theoretical area into theoretical velocity. Actual area by theoretical area is equal to coefficient of contraction, and actual velocity by theoretical velocity is equal to CV, coefficient of velocity. CD is equal to CC into CV. This is the relationship between CC, CV and CD. And this is the topic, and thank you for watching.